Welcome to our journey through the fascinating world of circles. In today's video, we'll delve into the fundamental properties and theorems that govern circles, unraveling the mysteries one by one. Let's start by familiarizing ourselves with some key terms associated with circles. The distance from the center of the circle to any point on its circumference is called as its radius. The diameter is the longest line that can be drawn inside a circle passing through its center. It's twice the length of the radius. Also, the diameter will divide the circle into two equal halves, and each half is called as its semicircle. A tangent is a line that touches the circle at exactly one point. That point is called as a point of tangency, and a tangent will always originate from outside the circle. An arc is a portion of the circumference of a circle, or it's a measure of the distance between 2 points on the circumference of the circle. With the theorem number 1, angles in a semicircle. Angles in a semicircle are created when you join the two ends of the diameter to one point on the circumference using chords. In the above diagram, AB is the diameter of a circle that divides the circle into two. The 2 points A and B are joined to another point C on the circumference using two chords AC and BC. This triangle is a right angle triangle with a 90-degree angle forming at the arc or point C. This is the same for any point that is placed on the arc. The angle in a semicircle is always equal to 90 degrees. This wraps up our theorem number 1, angle in a semicircle. Now let's move to the next theorem. Theorem number 2, angles subtended by the same arc. This theorem states angles subtended by the same arc at the circumference are always equal. The term subtended also means created or produced. In the given diagram, DB is an arc which subtends two angles A and C at the circumference of the circle. As per our theorem, angle DAB and angle DCB will always be equal. This holds true for any angle created at the circumference by the arc DB. Now let's try to understand theorem 3, which is angle at the center. This theorem states that the angle formed by an arc at the center is twice the angle formed by the same arc at the circumference. In the given figure, DB is an arc which forms two angles, A and C. A is formed at the circumference, whereas angle C is formed at the center. This theorem states that angle C will always be twice angle A. A key point to remember here is that this theorem only stands true if both the angle formed at the circumference and the angle formed at the center, are formed by the same arc. This brings us to the fourth and the last theorem of this video, tangent of a circle. This theorem states the angle formed between a tangent and a radius is 90 degrees. And it also states that tangents originating from the same point are equal in length. Before we dig deeper, let's recap what's a tangent. So, a tangent of a circle is a straight line that touches the circumference of the circle at only one point. An important thing to remember here is that a tangent always originates from outside the circle. And from one point, you can only draw two tangents to a particular circle. In the first figure, a tangent meets the circle at point A. Now, if you were to draw a radius from the center B to point A, then the corresponding angle formed between the radius and the tangent will always be 90 degrees. Now, looking at figure 2, there are two tangents originating from point A, which are AB and AD. Going by this theorem, AB and AD will always be of equal lengths. So, that brings us to the end of this video. In the next part, we'll be discussing some problems based on these theorems. I hope you enjoyed this video. Please don't forget to like, share, and subscribe to show your support. Thank you and see you soon.